There is question number 6. Simplify this expression here. Now let's just look at it for a moment. It's a bit tricky, this one. You have to think about it for a second. What are we allowed to do? Well, if we think about what we did in the previous question and think of that in terms of some numbers, I think you'd agree that 6 over 4 plus 2 is 1. But I can't write this as 6 over 4 plus 6 over 2. That doesn't come out to be 1. 6 over 2 on its own is just 3. So that doesn't work. I can't separate out each part of the denominator when it's added like that. In the same way that I could use this method in the first question, question 5 that we looked at. So I think of something different. However, if we think of this problem, 12 over 8 plus 4, I could decide I want to divide each of these terms by something. If I divide by a number that goes into all of these three terms, 2 goes into 12, 2 goes into 8, and 2 goes into 4. So I could divide each of these terms by 2. So long as I divide every term by 2, it works, because 12 divided by 2 is 6, 8 divided by 2 is 4, and 4 divided by 2 is 2. And if you look at that, it still gives the answer 1. They're both equal to 1. Note also, if I go back to this original question, 12 over 8 plus 4, there's a bigger number that goes into 12 and 4 and 8, and that's 4. So I could actually decide to divide each of these top terms by 4. Again, it works. 12 divided by 4 is 3, 8 divided by 4 is 2, and 4 divided by 4 is 1. And the answer is still 1. 3 over 2 plus 1 is still 1. So we can use that little trick here. The 4 is what's called the highest common factor. The biggest number that goes into 12 and 8 and 4 is 4. So how does that relate to a problem like this? Well, what we can do is we look at each of the symbols in this expression, the p and the q, and we look for the highest value of p. Well, if we look at the top term, we've got p cubed, and in the bottom, the first term has a p, the second term has a p squared, so the biggest, highest value of p that goes into all three is just p. So I can divide by p. Looking at the q, the highest value of q again is just q, because the bottom right hand term, this one here, only has one power of q in it, so I can only divide by q. So what I do is to take this expression, p cubed q squared over p q squared minus p squared q. I've just rewritten it, and I've done it like this, so I can now say, right, I'm going to divide top and bottom, each term in the top and the bottom, by the highest common factor for p, which is p, the highest common factor for q, which is just q. So I divide each of these terms by p and q, top and bottom. Remember, I have to divide every term by p and q. So now, looking at the top term, p's, looking just at this top, the denominator in here, this part here, looking at the denominator in there, p cubed divided by p is the same as p to the 3 minus 1, which is p squared. Q squared divided by q is the same as q to the 2 minus 1, which is just q to the power 1, or just q. So we end up with this equals p squared q. And if I do a similar thing with the bottom term for each of those, p to the power 1 divided by p to the power 1, they cancel, leaving just 1. Q squared divided by q, 2 minus 1 is just q. So the first term is just q, minus, I'm doing the same for the other ones, 2 minus 1 is 1, so it's just p, and q's cancel. So we're left with p squared q over q minus p, which is the solution in the textbook. Not an easy one, that one. Have a look at this question on the next slide. Exactly the same sort of idea. Look for the highest common factor for A and B and divide every term top and bottom by that highest common factor. The solution follows, so if you want to pause this video at this point and then have a look at the solution in a minute. Here's the answer. A squared b cubed. I could divide every term by a squared b squared. The highest common factor for A is a squared because it's at least a squared in each of the three terms. And the same for b. B squared, at least b squared in each of the three terms. So I could divide every term by a squared b squared to get the answer at the bottom. B over A plus A squared B.